everyone, welcome to the next session of fluid mechanics. In this session, we will be discussing about two more properties of fluids. One is called as bulk modulus and the other is called as compressibility. Let's talk about the first term, that is bulk modulus. It is defined as the ratio of increase in pressure to the volumetric strain. Let's talk about an example of a piston and cylinder. This is my cylinder. And say there is a piston here. Say there is some gas inside the cylinder. I am applying pressure P from this end. When I apply pressure P, this piston moves ahead to a new position. Say the initial volume was V1 and now the volume is V2. So when I say that the volume initially say the final volume after compression of the gas is V2. So the change in volume is say dV. Now pressure, when I say the initial pressure is say P1 and the final pressure is say P2, there is a increase in pressure that you will see. Let me say it is dP. So initial pressure is going to be low and the final pressure is going to be more. So it is P2 minus P1. And here this change is nothing but decrease in volume. The gas is occupying more space at the start. When you apply pressure, the volume reduces. That is, the space occupied by the gas reduces. So I can say there is a decrease in volume dV. And the final volume is obviously going to be less than the initial volume V1. So if you take again like this, final minus initial, you can understand that this value is going to be negative. So let's talk about the mathematical representation of bulk modulus. It is increase in pressure to the volumetric strain. So the increase in pressure is dP, that is final minus initial pressure. And when I say volumetric strain, it is change in volume to the original volume. So this change in volume is dV and original volume, say I call this as V1. Now the negative sign here indicates that the final volume is less than the initial one. The unit of K, that is a symbol for bulk modulus, can be found very simply. We know that volumetric strain is going to have no unit because strain has no unit as it is the ratio of same two quantities. The unit of pressure is say Newton per meter square or Newton per mm square, or Newton per meter square can also be called as Pascal. So unit of K is directly the unit of pressure. Next, let's talk about compressibility. It is the reciprocal of the bulk modulus of elasticity K. So I can say compressibility is 1 upon K. That's the simple formula for compressibility. If you want to know the unit of compressibility, then it is going to be reverse of the unit of K. So it will be meter square per Newton. Now let's take up a numerical on this topic. Determine the bulk modulus of elasticity of a liquid if the pressure of the liquid is increased from 70 Newton per centimeter square to 130 Newton per centimeter square. So it is given that the initial pressure P1 is 70 Newton per centimeter square. If you want, you can convert this into Newton per meter square or Newton per mm square. I am not converting as it will not be required. P2 is given as 130 Newton per centimeter square. The volume of the liquid decreases by 0.15%. So I can say that dV is decreasing by 0.15% of the original volume. So therefore I can say dV upon V1 is going to be 0.15 upon 100. I need to find bulk modulus K. For solution part, I can say K is dP upon dV by V1. Now dP is P2 minus P1. This dV upon V1 is directly known from here, 0.15 upon 100. Now you must be wondering why I am not using the negative sign, because the ultimate value of K, it is a modulus. It is never going to be negative. The negative sign was only indicating that there is a decrease in volume when the pressure increases. So I am not adding the negative sign. This value is 130 minus 70 upon 0.15 by 100. So when I solve this, I get the value of K as this is the value obtained. Let's take up another numerical. What is the bulk modulus of elasticity of a liquid which is compressed in a cylinder from a volume of, so initial volume is given as 0.0125 meter cube at 80 Newton per centimeter square. So P1 is also given. Pressure to a volume of, so V2 is given as 0.0124 meter cube and P2 is given as 150 Newton per centimeter square pressure. I have to find the value of K. So I'll write down K is equal to dP upon minus dV by V1. dP is P2 minus P1 upon dV. Let the negative sign be outside. Now here I am using the negative sign because I want to say that this is V2 minus V1, and as I take higher value which is subtracted from the lower one, automatically this will be negative in the bracket. Outside the bracket there is a negative sign, so total I am going to have a positive value. 150 minus 80 upon 0.0124 minus 0.0125 upon V1, that is 0.0125. When I solve this, I get the value of K as 8.75 into 10 raised to 3 Newton per centimeter square. So with this, I end this topic. I hope you have understood these two important properties of fluid. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.